Good morning, I am Kiran Raj. Welcome to the online classes on problem solving using C. Today we will discuss about the constants, variables and data type part 2. In the previous classes we have discussed about the different tokens that is available and constants. Today we will discuss about data type and the variables. Tokens can be divided into 6 categories: keywords, identifiers, constants, strings, special symbols and the operators. Operators are the mathematical operators that is available for you. Special symbols are the symbols again that is available for you, and operators and the special symbol, you can use any operator and the special symbol that is available with you or in your keyboard. Strings, the sentence that is enclosed in the double quotation, that is strings. Constants are those values which cannot be changed during the execution of the program. Identifier is just the name of the function or any data value. Keywords are those predefined words which has definite meaning and they cannot be changed. Constants, they can be divided into two types: numeric constants and the character constants, integer constant and real constant, a single character constants and the string constant. As it is already mentioned, they cannot be changed. And integer constants are the whole numbers, real constants are the which contains a decimal value or decimal point numbers. Single character constants are enclosed in the single quotation, and string constants, they are enclosed in the double quotation. Okay. Variables. What is variables? Variables are the data names that may be used to store the data value. In the previous classes we have used the program for calculating the simple interest. There we had terms called as amount, SI that is simple interest, P that is principal, T time, and R rate, right? What is that? Amount, SI, P, T and R, that is used to hold some value, right? So those are the names that is given. Data name that may be used to store the data value. In the amount, that is a name, I am storing or I am trying to hold the amount value, that some 10,000 or 20,000. In R, that is rate, I am trying to hold 3.5, that is 3.5 percentage, right? I am trying to hold that in the R. Okay. And variables are different from the constant. Constant value cannot be changed during the execution of the program, but variables values can be changed during the execution of the program. Now, rules to name the variable. The rules for naming the variable are pretty much similar to rules of the identifier. The first rule is it must begin with letter, and some system will permit underscore also. That is first condition. It going to recognize only 31 characters. More than 31 characters it will not recognize. And uppercase and lowercase are significant because C is case sensitive. If I am writing uppercase total and lowercase total, they are completely different. It should not be a keyword, and white spaces are not allowed. It may be tab, it may be new line or anything, but white spaces are not allowed. So you have the rules similar to your identifier rules, but make sure that variable names are understandable one or it is proper names. So I have listed some of the valid variable names. For example, John, amount, x1, my underscore account, that is my account, series 1 underscore 1. So your variable name can contain letters, underscore or digit also, but variable name cannot be started with the number. Similar to your identifier, you can start with letters. In certain system it will also permit underscore also. As I already mentioned, the upper case and lower cases are important and they are different. For example, if I am writing amount here, capital A amount and small letter amount, they are completely different. So they are completely different variables. Now let us see about invalid variable names. 1 John, because I am starting with the 1 and I am giving this space here in the my account, and I am using the operators, right? So that is not valid. Data type will tell us about the set of values and the operations that can be performed on those values. For example, when I am saying set of values, we are telling about whether it is character values, whether it is integer value, that is whether it is whole number, or whether it is real number, that is with the decimal point number, or whether it is very long number, like that. It is mentioning the domain or the set of values. And operation, they are speaking about whether it is addition operation can be performed, whether the subtraction can be performed, division, multiplication, modulus operation, percentage, which type of the bitwise operation, which type of the operations can be performed. So data type is used to identify the type of the variable when the variable is declared. So we come to know the type of the variable. So what is the use of getting the type of the variable? For example, if I am knowing that particular one variable can only store whole number, I can store only, I will come to know that I can only store whole numbers in them, and I will also come to know what are the operations that can be performed. On the whole numbers you can perform every operation, that is addition, multiplication, division, modulus, subtraction, uh, bitwise operation, you can perform everything. The second use is to identify the return value of the function. When you have any functions are present, the function will be also having the type. That is, function is going to return some value to the calling function. So we are able to identify what is the value that is returned back. And it is also going to identify the parameters expected from the function. In certain cases, the function will be containing one or more parameters, so we can identify the parameters type also. Data types can be divided into three types: primary or fundamental data types, derived data types, and user defined data types. In today's class, we will discuss about primary or the fundamental data types. Primary data type, what do you mean by primary data type? That is available with you, that is fundamentally available, right? So it can be divided into integer, character, floating point, and the void. Integer can be divided into signed and unsigned, and character can be again divided into char, signed char, and the unsigned char. Floating point can be divided into float, double, and long double, and then we have the void also. Signed and unsigned, it can be again divided into integer, short int, and long int. And again, on the other hand, we have the unsigned int, unsigned short int, and unsigned long int. So fundamental data types that is available with you, that is integer, int, char, float, double and void. They are the fundamental data types. Now let us come for the integer types. When I'm saying about integer type or integer, int, you are specifying that it can only store whole number. Whole means complete number. It should not have any fractional part or it should not have any decimal point. And what are the operations that can be performed? You can perform all the operations on the integer type. So let us see that integer types. The data type is integer, and when I am speaking about integer data type takes 2 bytes or 4 bytes. It will take 2 bytes or the 4 bytes depending on your machine. If your computer is of 16 bit, then it will consume 2 bytes. But if your system is of 32 bit or 64 bit, then it is going to consume 4 bytes of memory. Integer type can be divided into int, then we have the unsigned and signed also. So there we have again three categories, that is short, long and int. So let us go there. First integer, that is int. As I already mentioned, if your system is of 16-bit system, then it is going to consume 2 bytes. But if your system is of 32-bit or 64-bit, then it is going to consume 4 bytes. The range of the value that can be represented is this thing. These values can be represented. What you can do here is 2 bytes. So represent that in bits. 1 byte is 8 bits. So 2 bytes is 16 bit. When I am saying it is of integer or int type, the first bit is used for the representation of the sign. You may have come across this in the CO class, that is computer organization class. I have the 8 bits, that is now 2 bytes, right? I am speaking about 2 bytes. So 16 bits are there. When I am having 16 bits, the first bit, that is 16th bit, right? Higher one or MSD, that is used to represent the sign of the number. So when I am using the MSD to represent the sign of the number, that means I am going to have 15, right? One is used for sign, then the rest of them, right? 15 numbers are there with me. So 15 numbers are used to represent that thing, that is number range. So what you can do here is, just if you have the calculator, just type 2 to the power 15. You are going to get some number, that is 32,768. Now I already mentioned the first one, that is MSD, is used to represent the sign. So you have plus or minus. So minus 32,752 to plus 32,767. You may get confusion, why one lesser, because we have 0 also, right, in between. That is why. Okay. Again, when the integer is of 4 bytes, that means you are going to have 32 bits. 32 bit means, again the MSD will represent sign. So I have the rest of the 31. So 2 to the power 31. That will give me this value. and you can do the -1 here. Again, signed int, again it is similar to int only, no changes. But unsigned int, that means you are not going to have any sign. So MSD is also used to represent the number only. So that means what? Out of 16 bit, 16 bit is used to represent the number. That means I'm going to have 2 to the power 16. So calculate that, 2 to the power 16. I'm going to get 65,536. But since I'm going to start with 0, that means -1. Again, this is also same calculation, 2 to the power 32. While coming to int, we have two qualifiers, that is short and long. See why the qualifier was required, that is short and long. Integer can only store 2 bytes of the memory or 4 bytes of the memory. That means it can only store this value, 32,768, or till 65,000 it can store. Or in the, if it is in the 4 bytes, it can store up to 2 crore. But let me say that I want to store very bigger number. So how to do that? I have to give the more memory, right? So we started to use the long. If your system is of 16 bit, that means integer of 2 bytes. Then long will be of 4 bytes. If your system is of 32 bit or 64 bit, then your integer type consumes 4 bytes, then your long int, it will consume 8 bytes. In the same manner, short also, when you are having integer as 16-bit machine, that is 2 bytes, then it is going to consume 2 bytes. It is going to consume 2 bytes. But when your system is of 32 bit or the 64 bit machine, that time your integer type value is of 4 byte, but your short int will be of 2 bytes. Again, these calculations are similar to the integer calculation, and short int or short signed int and the unsigned short int, they are also pretty much similar to the calculation of the integer signed int and the unsigned integer. You can check the values also, they are pretty much similar. Short int and the signed short int, the MSB is used for the representation of the sign, so you are available with the only 15 bits, so that is the calculation here of 15 bits. While coming to unsigned short int, MSB is also used to represent the number, so you have that calculation which is pretty much similar to integer signed int and the short int, which is having 2 bytes. Long int and the signed long int also similar to integer only. The MSB is used for the signed representation, that is plus or minus. But while coming to the unsigned short int, the complete memory or the complete provided memory is used for the representation of the number. Floating point number. Floating point number is used to store the real numbers or the floating point numbers, or we can also say decimal point numbers. So we have main 3 types here: float, double and long double. Float consumes around 4 bytes of the memory and double consumes 8 bytes of memory and long double consumes 10 bytes of the memory. Now you may see the precision here, so you may get the doubt what is precision. The precision will tell us about how many decimal point is shown. For example, when I'm using float, that means I can show 6 decimal point. For example, 4.0000000, that is 6 decimal points. Or for example, 10.12345, 6 decimal places are shown. And in the same manner, for the double, I can show 15 decimal places, that is 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5. That much bigger decimal precision or decimal point value I can show. And anyhow, I have this side, that is on the left hand side I have the number, and on the right hand side I am going to have the decimal point. So what is the use? I can get the more accurate answer, right? Instead of 6 decimal point, now I have the 15 decimal point, so I'll get more accurate answer. In the long double also same manner, I'm going to have 19 decimal points. Decimal places are going to be there after the point. So I can have that much precision, or I can have that much accuracy in my answer. Character type stores the character. What is going to be stored? It is already covered in previous class. When you are mentioning or trying to store any character, the ASCII value of the character is going to get stored. I have already mentioned the table of the ASCII table, so you can refer that in the previous class video. So I have the char, and character types is going to consume only 1 byte of the memory. Char, that is 1 byte, signed char is also 1 byte, unsigned char is also 1 byte only. The calculation of this part is similar to your, that is range of the values is similar to your other integer types. The first one, or MSB, is going to represent your sign, and your unsigned char MSB is also used to represent the number. So if you want to store any character, that time you are going to use the char type, and most of the time you are going to enclose the char or character value in the single quotation. We will see that in the declaration part. The last type is void type. The void type specifies no value, or it specifies nothing. So when I have nothing, that time I am going to use void. So it is used in 3 kinds of situation. When the function will be returned as void, if you remember previous class, we have used the function void main. That means it is not going to return anything to the calling function. So function with no return values has the return type as void. That is void exit, then int status. But what is the type of the function exit? The type of the function exit is void. That means it is not going to return anything to the computer or to the system. Now, second situation, when the function arguments are void, that means I'm not going to pass any argument to the function. That time also your parameter list or the argument list will be void. For example, consider this example, integer, that is int rand void. Again, this is a function, random function. I am using the random function, and what I mentioned here, void. That means I am not passing any argument, or I am not passing any parameter. Now pointers to the void. Pointers to the void is mainly used when you want to represent the dynamic memory allocation. During those time we are going to have the pointers to. I am creating the pointer, but I am not mentioning what is the type of the pointer. I am only mentioning it is of void type. Void type means it is no type. Okay, I'm not mentioning the type of the thing here because it is of void type. Thank you.